Dear children, we are continuing our discussion on properties of vectors. Third one, unit vector. A vector having magnitude unity and having a definite direction is called a unit vector. Okay, so unit vector is always represented by a cap. This is a cap or a hat. So if A is a unit vector, means it is represented by a cap. And a cap or any unit vector is represented by vector, the corresponding vector divided by its magnitude. This represents the modulus of vector A, that means it represents the magnitude, its magnitude. Okay, and the unit vector along x-axis, y-axis and z-axis are represented by I cap, j cap and k cap. And here along the x-axis unit vector is I cap, along the y-axis unit vector is j cap, and along the z-axis unit vector is k cap. Okay, so this represents, its magnitude is 1. So it represents unit vectors along x-axis, y-axis and z-axis. So that is the importance of unit vector. For example, if a vector is represented by vector A equal to phi I cap. Okay, this means that the magnitude of vector A is phi and what is its direction along the x direction. So no need to write phi along or phi magnitude. If it is a force means phi Newton along x direction. If it is a velocity means phi meter per second along x direction. So no need to write that. Just write phi I cap. What does it mean? Phi is the magnitude and I cap represents the direction. So that is the importance of unit vector. If a vector is represented by velocity vector, vector v is equal to 2 j cap. What does it mean? 2 meter per second along y direction. Clear? The next property is zero vector or null vector. If a vector having magnitude 0 and can have an arbitrary direction is called a zero vector. Arbitrary direction means having an imaginary direction. Any vector whose magnitude is equal to 0 and can have an imaginary direction, that is called a zero vector. For example, for a stationary object is at rest. That means what is its velocity? Velocity is equal to 0, no? So, since velocity is a vector quantity, we can say that velocity is a zero vector. Now, another example, if the object, if when a moving object, initial position and final positions are same, then displacement is 0 or displacement is a zero vector. Then uniformly moving body, for a uniformly moving body, there is no acceleration. Acceleration is a zero vector. Then if an object is falling freely, okay, for a freely falling object, initial velocity is 0 or initial velocity is a zero vector. Zero vector is represented like this, 0 with an arrow. Okay, that means it is a zero vector. So for any vector, if its magnitude is 0, then we can say that it is a zero vector. Property, addition of vectors. We know that vectors cannot be added or subtracted by using ordinary law of algebra. To add two or more vectors acting in a plane, we have to use three important laws. First one, triangle law of extradition, parallelogram law of extradition and polygon law of extradition. For vector addition of two vectors, we can use triangle law or parallelogram. More than two vectors, then we have to use polygon law of vector addition. For your syllabus, you have to study only triangle law of extradition and parallelogram law of extradition. First one, triangle law of extradition. Consider two vectors, vector A and vector B. These are the two vectors, vector A and vector B. We have to add these two vectors by which method? Triangle law of extradition. For that, we have to shift any one vector, okay, either vector A or vector B, so that the tail of one vector touches the head of the other. That means this is tail, head. Okay, this is called a tail and this one is called a head. So change or shift any one vector so that tail of one vector touches the head of the other. That means we can shift this vector, vector B, so that, okay, we can shift vector B so that the tail of vector B touches the head of vector A, like this. This is vector A. Okay, this is vector A. We can shift vector B like this. We can shift vector B so that the tail of vector B touches the head of vector A. So we have to shift like this without changing the magnitude or without changing the direction. We have to shift like this. This represents vector B. Is it clear, children? So this is vector A, this is vector B. Shift any one vector so that the tail of one vector touches the head of the other. So we can shift vector B like this so that its tail touches the head of vector vector A like this. Okay, so this shows tail, head, tail, head. Then according to triangle law of extradition, the resultant is given by the third side of the triangle. We can consider these two as the two sides of the triangle. Then the resultant is given by third side of the triangle taken in the opposite order, reverse order. So resultant is given by R equal to vector A plus vector B. Okay, so this is triangle law of extradition. What is triangle law of extradition? If two vectors represents two sides of a triangle taken in the same order. Same order means tail, head like that. Okay, then resultant is given by the third side of the triangle taken in the reverse order. Reverse order means this is opposite order. Okay, so this is called the triangle law of vector addition. Or otherwise we can shift like this also. We can shift vector A. We can shift vector A so that its tail touches the head of vector B. Okay. So, or there is no change in vector B. This is vector B. Vector A can be shifted so that its tail touches the head of vector B. Okay, children? Okay. So these are the two vectors. Vector B is intact. I have changed the position of vector A. Vector A is shifted here. Clear? Now according to the triangle of extradition, the resultant is given by third side of the triangle taken in which order? Reverse order means like this. Okay, so this represents resultant R equal to vector A plus vector B. So is there any change in direction of the resultant? In both the case, the direction of the resultant and magnitude and direction remains same. Okay, so either we can shift vector A or we can shift vector B. Then the resultant is given by third side of the triangle taken in the reverse order. Hence, this is the rule. If two vectors are represented by two sides of a triangle taken in the same order, then the resultant is represented by the third side taken in the opposite order. Two vectors are represented by the two sides of the triangle taken in the same order. What does it mean? Tail, head like that. Then the resultant is given by third side taken in the reverse order. So this rule is called a triangle law of vector addition. So this method is otherwise called a head to tail method of vector addition. Okay. The second rule of vector addition is parallelogram law of vector addition. Here also we can consider two vectors, vector A and vector B. Okay, so these are the two vectors, vector A and vector B. Now in parallelogram law of vector addition, we can shift any one vector so that both the tails are joining together. Okay, or both the heads are joining together. So we can shift any one vector so that both the tails are joining together. So we can shift like this. We can shift vector B slightly so that its tail touches the tail of vector A. Okay, there is no change in magnitude or direction. So this is vector A. This represents vector B. Okay, children? This is vector B. Okay, so shift any one vector so that both the tails are joining together. Then these two represents the two sides of a parallelogram. Okay, then resultant is given by, we can complete the parallelogram. We can draw a parallel side. Here we can draw a parallel. Here also we can draw a parallel. We can complete the parallelogram. Then according to the rule, resultant is given by the diagonal of the parallelogram starting from the same point. Like this. So resultant is given by the diagonal of the parallelogram starting from the same point, means all the tails should be joining together. If both the heads are joining together means the resultant head should be at the same point. So this gives the resultant R equal to vector A plus vector B. So if two vectors represents two sides of a parallelogram starting from a point, then the resultant is given by the diagonal of the parallelogram also starting from the same point. Okay, so here vector A and vector B, two vectors vector A and vector B, shift in one vector so that the tail of one vector touches the tail of the other. Then these two represents the two sides of a parallelogram, complete the parallelogram, and the resultant is given by the diagonal of the parallelogram. Hence the rule is, if two vectors are represented by the adjacent sides of a parallelogram having a common origin, then the resultant is represented completely by the diagonal of the parallelogram passing through the same origin. So this is parallelogram law of vector addition. Thus we have studied triangle law of vector addition and parallelogram law of vector addition. Okay, just I am concluding what we have studied. So we have two vectors vector A and vector B. We can add the two vectors by triangle law of vector addition like this. Shift one vector so that the tail of one vector touches the head of the other. So we can shift B like this, and so that its tail touches the head of vector A, isn't it? So resultant is given by the third side of the triangle taken in the reverse order. So this is the resultant. If we are adding the two vectors by parallelogram law of vector addition, we can draw like this. This is vector A, same, and vector B is shifted so that its tail touches the tail of vector A, isn't it? So it represents the two sides of adjacent sides of a parallelogram, complete the parallelogram, and the diagonal gives the resultant. So either we are using triangle law of vector addition or parallelogram law of vector addition, the resultant remains the same. The resultant direction in both the case same, and magnitude also will be same. So for the addition of two vectors, we can use either triangle law of vector addition or parallelogram law of vector addition. Okay children? Now we can study how to find the magnitude and direction of the resultant of the two vectors vector A and vector B. We studied the vector addition can be done by using parallelogram law of vector addition and the triangle law of vector addition. Here consider two vectors vector A and vector B, and the resultant is given by the diagonal of the parallelogram, isn't it? So this gives the resultant. Then what is the value of this R? So if A is a vector, B is a vector, R is another resultant. R is the sum of the two vectors, vector R equal to vector A plus vector B. But R is not equal to A plus B. That is the important thing. Okay, A and B are vectors, but the sum of the two vectors is vector R. R is not equal to A plus B. We have to find out the value of R. R is something different. So how will you find out the magnitude of the resultant R? That is, we are doing it now. Consider two vectors vector A and vector B. Let the angle between them is theta. Consider two vectors vector A and vector B are at an angle theta between them. Okay children. Now how will you find out this R? For that, let this is OA, this is OB. Draw a perpendicular from, let this is R. Draw a perpendicular from R to this OA. We can extend that OA like this. We can extend and draw a perpendicular from R. Okay, draw a perpendicular. Let that point be N. Okay, so that is N. Here this angle is theta. What is this one? This is also theta. Now if you consider the right angle triangle ORN, consider the right angle triangle ORN. This is the hypotenuse. What is its magnitude? R. So R square equal to here ON. ON square plus RN square. Isn't it? OR square is equal to, using the Pythagoras theorem, OR square equal to ON square plus RN square. This is 90 degree. So R square, OR equal to R. So R square plus is equal to ON square plus RN square. Is equal to, what is this value of ON? ON equal to OA plus AN, isn't it? OA plus AN, the whole square plus RN square. RN square equal to R square. OA, what is the value of this OA? OA is magnitude is A, but A is unknown value. Rn is also an unknown value. So we have to find out the values of AN and Rn. For that, if you consider this right angle triangle ANR, this right angle triangle ANR, consider right angle triangle ANR. Take sin theta. What is this sin theta? If you consider this triangle, sin theta is equal to opposite side. Opposite side is Rn divided by hypotenuse. What is the value of hypotenuse? AR. Okay, this is 90 degrees. So opposite is the hypotenuse. So consider triangle ANR. Sin theta can be written as, what is the value of sin theta? Sin theta is equal to Rn divided by AR. Okay children, so what is this Rn? That is unknown value. Rn divided by AR. AR is equal parallel to this OB, no? OB is equal to magnitude B. Similarly, AR is equal to magnitude same value B. So what is the value of Rn? Rn equal to B sin theta. So Rn is equal to B sin theta. So the value of Rn is B sin theta. Similarly, consider the same triangle, right angle triangle, take cos theta. What is the value of cos theta? Cos theta is equal to adjacent side, that is AN divided by hypotenuse. What is the hypotenuse value? AR, isn't it? So cos theta is equal to AN divided by AR is equal to AN divided by the value of AR equal to B. So B. So AN equal to B cos theta. Okay, so we got the value of Rn and AN. Then substitute the values of R and AN in this one. This is the first equation. Substituting in the first equation, we can write R square. First equation is R square equal to OA plus AN the whole square plus Rn square, isn't it? So substituting, we can write R square equal to OA. What is the value of OA? A. So A plus AN. We got the value of AN as B cos theta. B cos theta the whole square plus Rn. Rn equal to B sin theta. B sin theta the whole square. Here A plus B the whole square, that form it can be written as A square plus 2AB cos theta plus B square cos square theta plus B sin theta the whole square is B square sin square theta is equal to A square plus 2AB cos theta. From these two terms, B square can be taken common. So plus B square into cos square theta plus sin square theta. Sin square theta plus cos square theta. Sin square theta plus cos square theta is 1, isn't it? So it is equal to A square plus 2AB cos theta plus B square. So R square, the value of the resultant, R square equal to A square plus 2AB cos theta plus B square, or the value of the resultant R equal to, we can write root of A square plus, we can rearrange it, B square plus 2AB cos theta. So if two vectors are there, vector A and vector B, and theta is the angle between them, the value of the resultant is R equal to root of A square plus B square plus 2AB cos theta. Okay children. Now how will you find out the direction of the resultant? In order to find out the direction, let this angle is alpha. Alpha is the angle between vector A and the resultant. Let alpha be the angle between vector A and the resultant. Let that angle is alpha. So in order to find out the direction of the resultant, we can take tan alpha. That is the easy method. Tan alpha. If you consider this right angle triangle ORN or triangle ONR, triangle ONR, okay, this right angle triangle. From the right angle triangle, what is tan alpha? Tan alpha is equal to opposite side divided by adjacent side, isn't it? Opposite side is RN divided by adjacent side is ON, isn't it children? Tan alpha equal to opposite side divided by adjacent side. Opposite side is RN divided by adjacent side is ON. You can substitute the value Rn. What is the value of Rn? B sin theta divided by On. On equal to OA plus AN. What is the value of OA? A. Plus what is the value of AN? AN equal to B cos theta. So tan alpha equal to B sin theta divided by A plus B cos theta. So this is the value of the result, direction of the resultant. Okay, so direction of resultant is usually represented by tan alpha and it is given by B sin theta divided by A plus B cos theta. Okay, so this is the method of finding magnitude and direction of resultant of two vectors, vector A and vector B. R equal to root of A square plus B square plus 2AB cos theta, and tan alpha is the direction of the resultant.